work on another Leetcode problem called sort color. Let's get started. Okay. So given an array nums with an object colored red, white, or blue, sort them in place. That means we are not allowed to use any additional data structures, so that the object of the same color are adjacent with the color in the order red, white, and blue. We will use the integer 0, 1, and 2 to represent colors red, white, and blue respectively. You must solve this problem without using the library sort function. So personally, when I read this problem, I go after that to the constraint. Here, the good hint in the constraint that nums of I is either 0, 1, or 2. It's also mentioned here in the problem description. Okay, and the size of the array, it's between 1 and 300. Okay, so usually the first step for solving any Leetcode problem is to understand the problem. What is the input? What is the output? So here the input is just an array of integer, and the output is the sorted version of this given input array. Okay. So after understanding, we need to match it. Matching is pretty much how we can match it with the categories of problems like linked list, dynamic programming, and other strategies for solving the Leetcode problems. So apparently two-pointer solution will work well here. Okay. With the left, right pointers, 2 pointers with additional pointers that scan the whole element in the array. Okay. So what we can do here, the plan is to take 3 pointers variable. So here I like left, middle, right pointers, but you could call them like whatever, like start, end, and I index. Then after you initialize your pointers, move all the zeros to the left, 1 keep it in the middle, move it to the right side of the array. Okay. So match, we finish the match, and we said that's two-pointer solution. It's work all here. And sorting, we cannot use any language for sorting, or in other words, any sort library. And we talk about the plan that we need to swap and then scan all the elements in the array, and we need the 3 pointers and so on. Let's move to the implementation, and I put here side by side my Java solution for solving this Leetcode problem. Okay. Okay. So let's take these examples as an input array, and we would like to sort it to 0, 1. And again here, the first step, the first 3 lines of my code is just to initialize the 3-pointer S, I, and E. So S will point at the first element in the array. I will do the same thing. E will point at the last element in the array. By the way, I mentioned about that. I just want to remind you that I is just pointer for scanning the whole element in the array. S, it's kind of a pointer that's point to the 0 sections, and E is just a pointer that's point to the 2 sections, because we want to keep a track where we need to insert the 2 and 1 in the array. Okay, so our condition here is as long as I is less than or equal E. So as you can see here, I is 0 less than or equal to 2. That means we are good to go. And then we have 3 conditions to check: if nums of I equal 2, if nums of I equal 0, or if nums of I equal to 1. Just keep moving to the next element in the array. Okay. So here it's I is pointing at the 2. Nums of I is equal to 2. That means we need to swap I with E. So 1, it will be moved to the left, and right to go back to the right side of the array. We swapped I with E, and then we're gonna update the pointer I by decremented. So E then we're gonna update the pointer E by decrementing the pointer E. Okay, and we're gonna keep the pointer I pointing at the same location, since a new value came from the back of the array. So right now the new value at index 0, it's 1, and we said if the value is 1, just we need to update the pointer I. Now I is pointing at 0, and we said if the nums of I equals 0, that means we need to swap I with S. Okay, so we're gonna swap I with S here, and after the swap we need to increment I. Okay, so we increment I and then increment S. So if you check here, so S minus 1, so S is pointing at 1, minus 1, this location or this section for 0. And if you check E plus 1, this location for all 2 element, and 1 in the middle. So here I is pointing at the 2 index, or in other words, after updating the I index, it will be 2, and then E it's 1. That means our condition will be evaluated to false, and then we're gonna stop. And after exit the while loop, we will get a sorted array. Okay, so let's check this another examples. Similar to what we have done, E will initialize it toward the end of the array, last element in the array, S and I at the first element in the array. Then we said if the nums of I equal 2, we're gonna swap I with E. I'm gonna copy this one because we need this one here. If nums of I equal 2, that need to swap I with E and decrement E. Okay, so here we're gonna swap and decrement. I'm not gonna do the whole swap because pretty much there is no actual update. It's just value. It's just the same values will be written or rewritten again. Okay, and then after decrement E, the value at I, it will be 2, that came from the back. Then we're gonna swap the I with E again. Okay, that's mean to me this 2 will be here, this 2 will be copied here, and then this 2 from back, it will be here. So some point like that, something like that. Okay, and then after that decremented, actually it's here, sorry for that, it's here and there. And then we need to decrement E, and the same thing which it will happen, and then decrement E again, and decrement E again. Okay, that's mean this with this value, it will be swapped. Then decrement E again, or decrement E again here, that means the same value by itself which will be replaced. Okay, that means here we're gonna replace 2 by itself. The last step, I will be 0, and with that we're gonna evaluate this condition to false, and then we can exist. Okay, since we didn't do any actual sorting, we just move I toward the left of the array, and S and I stay at the same positions. Okay, so if you check here again, all the element, so here at index 0, 0 plus 1 from 1 toward the end, it's all 2 element. With that being said, I hope this solution it help you. The last step I want to mention, it's about the evaluations. So the time complexity, it's O of n, since we're gonna touch every single element in the array. For the space complexity, it's O of 1, since we didn't use any additional data structure. All right, with that being said, I hope this tutorial was helpful.